Okay, so in the last session we started with queue data structure, and we have seen the concept of queue. We have studied the queue ADT. Then we have seen different possible operations on queue, and then we started with the implementation of queue using arrays. Okay, so today we will be completing our implementation of queue using arrays, and then we will proceed for the next topic. So before that, let me again remind you what is queue. A queue is a linear data structure in which a data is inserted from one end and it is deleted from another end. So you can think of a queue as some sort of a pipe where the two ends are open. One end from where the things are inserted is called as the rear end, and the end from where the data is deleted or the things are deleted or removed is called as the front end. So that is called the front of a queue, and the end from where the data is inserted is called the rear of a queue or the rear end of a queue. Okay, so in the implementation part, what we have seen, then we have seen the different operations on queue. Just like the operations on stack, a queue can be initialized. We can check whether the queue is empty or not, queue is full or not. Then inserting a data into a queue, which is also called as insert operation, or it is also called as enqueue operation. Then deleting a data from the front end of a queue, which is called as a delete operation, or it is also called as a dequeue operation. So enqueue is insert and dequeue is delete. Then in the implementation, we have seen this, that inner structure for the queue will be having an array because it's a implementation using arrays, and two more variables. One is to keep track of the front element and one is to keep track of a rear element. Now both these variables will be tracking the front and the rear elements of the queue using the indices. So both the elements or both the variables will be holding the index value. And when the queue is empty, both can have a value of -1, indicating that the queue is empty. And the insertion is done from the rear end. So to check whether the queue is full or not, we need to check this rear variable value. Okay, so if the rear variable value is equals to the max size of the array -1, then we say that the queue is full. Then to initialize the queue, we set both the variables front and rear as -1. That's what we have done in the initialize function. Then to check whether the queue is full or not, the condition is if the rear is max -1. So if my queue of rear equals max -1, so it is full. So in that case, we would be returning 1, else we would be returning 0. Okay. Then the empty condition, any of the variable front or rear can be tested for -1. If any of the variable is -1, it means that your queue is empty. So in that case, we would be returning 1, else we would be returning 0. Then we were talking about the insert function, or you can also call it as enqueue. So what is done inside the insert function? It's an insert function just like the push function of a stack. So you will be passing two things to this insert function. One is the queue in which you need to insert the data, and second is the data itself. Now, since whatever changes we are making into this function, those changes we need to see in the calling function. That's why when we pass a queue, we make use of pass by address method. Okay, just like your stack, exactly like your stack. So here we'll be passing a address of a queue. So in this function, we need a pointer of a structure queue type to accept that address or to hold that passed address. Second is the data to be inserted in the queue. Now, since we are maintaining or we are storing an integer type of data into the queue, that's why this variable will be of type integer. It is as simple as that. Then, inside the function, what we will be doing, before the insertion, you need to check whatever kind of data structure it is. If you are inserting a data into the data structure, first we need to check whether that structure is full or not. If the structure is not full, then only we can insert the data. If the structure is full, then we cannot insert the data. Okay. Likewise, whenever you are going to delete a data from any data structure, you need to check if the data structure is empty, we cannot delete a data. If the data structure is not empty, then only we can delete a data. This is a very simple thing, a straightforward thing. So it is applicable for the all types of data structures. So before the insertion or inside the insert function, before the insertion, we'll be checking whether the queue is full or not. If the queue is not full, then only we'll be inserting a data. So we are calling the isFull function, and we are simply writing here queue. Why? Because queue itself is a pointer. It is storing the address. That's why we are writing queue and not ampersand queue. Then if the queue is full, if it returns 1, then from this function we are simply returning 0. What does it mean? The return type of the function we have set as int. Now why we have set it as int? We want to return a true value or one value from this function if the insertion is successfully done. And if for any reason the insertion is not successfully done, then in that case we would be returning 0. Okay. So if the queue is full, it means that you cannot insert, and that's why we are returning 0 from this function. Okay. If the queue is not full, then this condition will fail and will not execute this statement. Instead, then we'll come back to this statement. What we are doing here, insertion is done from the rear end. Before inserting a data into the array, we need to increase the value of the rear index variable. So we will be writing plus rear, pre-increment operator, because in a single statement we are writing there queue of data and in square bracket the index of the array at which the new data should be inserted. Okay, so queue of data in square brackets plus queue of rear. You must write plus queue of rear. If you write queue of rear plus, so that's a post increment. So whatever is the value of rear, that value will be used as an index. Into that index value, the value of d will be stored, and then the rear value will be incremented by 1. We don't want that. What we want, as per the initialization of rear and front, which is -1, what we want, that the value of rear should be incremented first, and then into that incremented index value, the new element should be inserted. That's why we are writing plus queue of rear. So our statement becomes queue of data in square brackets plus queue of rear equals to the given data element, that is d. Then here the insertion is done. After insertion, we need to check whether this insertion is the first insertion. What I mean to say, if the queue is empty, then both the variable front and rear are -1. So when the data element is inserted for the first time, what this statement would do, this statement, queue of data in square bracket plus queue of rear. So queue of rear was -1 plus queue of rear would make it 0. Okay. So this becomes queue of data in square bracket 0 equals to d. Whatever data you have given, you have passed. Okay. So that data is now stored at the index value 0. And this is the first insertion. This is the first element of my queue. At this time, in this situation, the value of front is still -1. So that's what we are checking over here. If queue of front, if the front variable of the same queue, if queue of front double equals -1, so we are setting it to 0. We must set it to 0. Otherwise, it would remain -1, and then you cannot delete any element, because the deletion in a queue is done from the front end. Insertion is done from the rear end, and deletion is done from the front end. That we need to remember always. That's why we are setting, or we are first checking, if my queue of front is -1, then I need to set it as 0. So if queue of front equals -1, it means that the insertion which we have done just now was the first insertion, and in that case my front variable should be set to 0. So queue of front equals 0. That's all. And then The last statement is return 1. Why return 1? Because we have successfully inserted an element into a given queue. Okay, we have successfully inserted an element, a given element into the given queue, and that's why we are returning 1. So this is the insert function. Once the insert function is done, once this operation is done, so the next operation is delete function. Deleting an element from the given queue. This is also called as DQ. DEQUEUE. DQ. Insert function is also called as NQ. Insert function is also called as NQ. ENQUEUE. This is my delete function. Delete function is also called as DQ. Okay. So just different terms, no need to get any confusion. So what we would be doing inside this function, again a simple implementation. Please always remember that we are trying to keep the structure of the program same. The way we did implementation of stack using arrays, the same way we are trying to do the implementation of queue using arrays. Okay, we are trying to make the program as general as possible, and we are trying to make the program as modular as possible. Okay, so for different operations we are writing different functions, and to keep it general, we are passing the queue, we are passing the data structure to these functions, and accordingly these functions are doing their task. Okay, so to this delete function, as we did in the pop function of a stack, what we are doing, we are passing a queue from where the element is to be deleted. Now when we say we are passing a queue, we mean to say we are passing an address of a queue from where the element should be deleted. Now since we are passing an address of a queue, inside this function we need a pointer to accept that address. And that's why the argument of the function becomes struct queue star queue, a pointer to a structured queue. Okay. Then this delete function is having a return type as int. Why? Because after deleting an element, after successful deletion of an element, after successful DQ, we are returning a deleted element. Now since we are returning a deleted element, okay, that's why the return type is Q. Why? Because we are storing a integer. That's why the return type is int. Sorry. Why? Because we are storing an integer type of data into a queue. And since you are storing an integer type of data into queue, whenever you delete, you will be getting an integer. That's why the return type of the function becomes int. What we are doing into this function, the deletion in a queue is done from a front end. Remember this. Before deletion, we missed here something. What should be done before deletion? Can someone answer? Please answer into the chat box, or you can answer me by unmuting your mic. Good, very good. We need to check whether the queue is empty or not. Absolutely. Right. How to do that? What I need to write after this int d? In C programming language, in between what we will keep on doing, in between we'll keep on exchanging some tips and tricks of C programming language, or some important things about C programming language. So in C programming language, you can have a declaration of the variables immediately after start of block. I repeat, in C programming language, we can declare the variables immediately after start of block. Now, what do you mean by start of block? In C, start of block is opening curly braces or the left curly braces. I repeat, in C, C++, even in Java, start of block is represented using opening or left curly braces. It means that this is my start of block. Okay. This is our start of block. So in C programming language, you can declare the variables immediately after start of block. It never means that you can only declare the variables immediately when the function is defined or at the first, second, third line of the function definition. Even if you have a block in between the function, for example, a loop. Okay, so you have one loop and then you have the block for that loop. So immediately at the start of that block also you can declare the variables. Very well, not an issue. Only thing what you need to remember, the block in which a variable is declared, that is the life scope of that variable. I repeat, the block in which the variable is declared, that is the life scope of that variable. It simply means that after whichever start of block a variable is declared, now the variable's life will exist, or the scope of the variable will exist unless and until it is static or global. So variable of that life of that variable will exist only until the corresponding end of block or the corresponding right curly braces. So this is the closing curly braces for this opening curly brace. Okay. So the life of this variable D is up to this point. Likewise, for all the variables. Inside the main function here, I have a variable ch and d. Okay. So this is the start of block for these variables and even for this q. Okay. So whichever is the corresponding end of block for the start of block, until that point, these variables will have their life. So this is this last one is the end of block for that start of block. So those variables will be having life up to this point. After this point, no life. What does it mean? If you declare any variable inside this while, which you can do very well. Okay. So here also I can have one variable, say int x. Absolutely possible in C. So when I declare a variable just after start of block, which is valid in C, only I need to remember that whatever is the closing curly brace for this opening curly brace, up to that point only the life of x will be there. Okay. So this is the closing curly brace of that opening curly brace of the while loop. So x is accessible only up to this point. After this, if I try to access x variable, it is invalid because x does not exist after that block. Okay, so that you need to remember in C programming language. So we were talking about delete function. Okay, so here we are missing check for an empty queue. If the queue is empty, we cannot delete. So here I would be saying if my queue is empty, if is empty, what I need to pass, simply queue. If this is the case, if my queue is empty, then I can simply say print f slash n queue is empty. Into the else part, I would be doing into the else part, we'll be doing all this stuff. So if is empty queue, we are simply printing queue is empty. Else, if the queue is not empty, then what we are doing? We are deleting from a queue. Now the deletion is from the front end after deletion of an element, we need to increment the front by 1. Okay. So what we are doing here, d equals to, we have taken one variable of int type, that is d. So d equals to q of data, q of front. So whatever is at the front of a q, now that is taken into d. That's all. After this, there is a check. If q of front equals q of rear, then q of front equals to q of rear equals to -1. Else q of front equals to, q of front plus plus. Can someone tell me what is this? Please. You should say me the answer. I can expect an answer for this because it is not that difficult and it should be quite straightforward. You need to just tell me what does it mean. Please try to see it very carefully. What we are doing, first we have taken the element which is present at the front position. Okay. So d equals to q of data in square brackets q of front. So you got the element which is at the front position. Then after that I am checking for the condition if q of front double equals q of rear. So what does it mean? If this condition is true, then I am simply saying q of front equals to q of rear equals to -1. I am setting both the variables as -1. If this is not the condition, if q of front is not equals to q of rear, so in that case I am just incrementing the value of front. So else q of front plus plus. What does it mean? Alfia says if it is the last element, then q is empty. So front rear equals to -1. Then Daniel says if q has only one element, index of front and rear set to -1. Okay. Excellent. Both are giving the correct answer. Anybody else? Okay, I have said you this answer is the correct answer. What they are saying, they are simply saying that if whatever element you are going to delete, if that element is the last element, is the only element in the queue, okay, so in that case your front variable and your rear variable both would be pointing to the same element. I repeat, if there is only one element in the queue, if it is the last element of a queue, if there is only one element, then obviously it is the last element, first and the last element of a queue. Now since that single element is the first element, that single element is also the last element, so front is pointing to the first element, so front is pointing to that element only, and rear is pointing to the last element, so rear is also pointing to that element only. So front and rear both are pointing to the same element. Now since both are pointing to the same element, so front and rear both are what? Indices. They are index values. So since they are indices, they are pointing to the same element. It means that front and rear both are having the same value. Front and rear both are having the same value. So it means that front and rear both are having the same value. So that's why we are putting a check if q of front double equals q of rear. So the element which we are deleting now is supposed to be the last element. Now since this element is the last element, so our queue is getting empty, and since our queue is getting empty, we are setting both the variables to -1. So q of front equals to q of rear equals to -1. That's why we are writing if q of front equals double equals q of rear, so both are pointing to the same element, and that element we are deleting now. We are deleting that element. So since we have deleted the last element, so it means that the queue is empty, and that's why I am setting q of front equals to q of rear equals to -1. Queue empty. Done. Else, if this is not the case, it means that you have more than one element in the queue. Now since you have more than one element in the queue, front and rear both are different, both are pointing to different elements, and you have deleted the element from the front end, so your front should be incremented by 1. Only your front should be incremented by 1 without touching the rear index value, or without touching the rear variable we will be only incrementing the value of front. That's why in the else part, if this condition is false, it means that you have more than one element. If this condition is false, you have more than one element. You have deleted only one element from the front end, and that's why in the else part we are writing q of front plus plus. What we are writing? Q of front plus plus. Then the element which we have deleted, that is this statement, d equals to q of data of q of front, that element we are returning. So return d. That element we are returning. So we are writing return. So I hope you have understood this. So the return. So the return statement is return d. Okay? And this is the last statement of the delete function. And this way we are completing the delete function. And what we have done, we have implemented initialize function, we have implemented is full, we have implemented is empty, we have implemented insert, we have seen delete function, and now we need to see the display function. Display function means what? You need to display the content of a queue. Just try to visualize that when you display the queue, how the queue should be displayed. How our stack was displayed? How did we display the stack? From top. We displayed the stack from top. The topmost element should be displayed first, then second topmost element, then third topmost element, and so on. So in the display function of the stack, we started from the top variable. So for I equals to s of top, then I greater than equals to 0, I minus minus. Okay. But in case of a linear queue, or in case of this simple queue, when we are displaying a queue, how the queue should be displayed? It should be always displayed starting from the front element and going up to the rear element. So it is something like front to rear. Okay, it should be displayed in the form front to rear. So our loop becomes what? For I equals to q of front, and always, since it is a linear queue, a simple queue, front is always going to be smaller or at the most equal to rear. Okay, so we'll be starting from front. So for I equals to q of front, I less than or equal to where I plus plus. Okay, I less than or equal to q of where I plus plus. Let's see the display function. That is the important thing I am talking about. That is indexing for the for loop. So inside the display function, this is my display function. What we will be doing? Obviously, we'll be checking if the queue is not empty, then only we'll be displaying something. If the queue is empty, then we'll be simply displaying that the queue is empty. So here the check is if is empty queue, printf queue is empty. Obviously else, then printf queue content, some proper presentation on new line. Then okay, here the few more information we are displaying. We are displaying the size of a queue, then we are displaying the value of front, and then we are displaying the rear also, value of rear also. So size of a queue is the value of max, and value of front is q of front, and value of rear is q of rear. Okay, so that information also we are displaying, and then we are displaying the content of a queue. And how we are displaying the content of a queue? With this for loop, for I equals to q of front. So we are starting from front. I is less than or equals to q of rear. We need to go up to there, and then I plus plus. Then inside this for loop, we are displaying an integer type of data because we are storing an integer type of data into a queue. On every new line, we are displaying q of data of I. This statement. Q of data of I. Okay. So this is the main part of a display function, and this way we complete the display function. Then apart from a display function, I have one more function into the queue. What happens most often? You have one more operation on various data structure, and that operation is called as a search operation. You are given with a data structure, and you are also given with an element value, and you need to check, or you need to find out whether the given element is present into the given data structure or not. Okay, if the given element is present, you need to return the location of that given value. I repeat, you need to return the location of the given value. Okay, if the given value is present in the given data structure. If it is not present, then you can simply return a value indicating that it does not exist, or it is not present. Now, this operation is applicable to almost all data structure. I repeat. So you can be asked to write a function to search a given value into a stack. You can be asked to write a function to search a given value in a queue, and likewise for various different data structures. So I have a search function for the queue over here. It is implemented in a very simplest way. What we are doing, a search function, the name of the function is search, and we need to pass two things. One is the data structure in which you need to search, and another is the thing which you need to search. Okay, so here the data structure is queue, so we are passing a queue to this, and to keep all the functions same, we are passing an address of a queue. Otherwise, we do not need an address. Even if you simply pass a variable of a queue, that will also do. But to keep it same everywhere, we are passing a address of a queue, and so we need a pointer to accept that address, and that's why the first argument is a pointer to a structure queue. The second argument is the integer type of variable. Why integer type? Because we are storing an integer type of data into a queue. So if you are searching for any element, that element should be of integer type. Generally, search elements are called as key value. The element which we generally search into any data structure, those elements are called as a key value. Okay, so I have just named it as K. You can call it as key also, no issues with that. Then we are having one dummy variable int I. How we are searching? We need to start from the first element. We need to go up to the last element. And what we need to do, start with the first element, compare the given element with the first element. If the given element equals to the first element, so the given element is at the first location, so we'll return the location of this first element. If it is not equal, then we'll move to the next element. Compare the given element with the next element. If the given element equals to the next element, then return the location of this next element. If not equal, then go to the next element, third element. Compare the given element with the third element. If they are equal, then return the location of the third element, else compare with the next. Keep on doing this till you reach the last element, which is pointed by the rear index value. And when this element is also not equals, if the given key element is not equal even to the last element, it means that you have checked for all the elements of the queue, and the given element is not present in the queue. So in that case, you will be returning a value which can indicate that the given key element does not exist in the given data structure. Now, since this implementation is an implementation using arrays, so you cannot have the index value as -1. Okay? And what we are returning from this function index value? If the element is present in the queue, so we are returning the index value where the element is present. Okay, if the element is not present, then we can safely return -1. Then we can safely return -1. Okay, again we are starting from the first element. For I equals to q of front, I less than equals to q of rear, I plus plus. So we are starting from the first element and we are going to the last element. What we are doing inside the for loop, we are simply checking if q of data of I double equals to the given key value, that is k. So if q of data of I double equals k, it means that we have found the given value k at the index position I. If they are equal means we have found the given key value k at the index position I. So if this condition is true, we will say return I. That's all done. We will return from this function. The moment we find the given value k at any index position, we'll return that index position. Okay. So if this condition is true, we'll return I. If this condition is not true, then we'll check for the next element. I plus plus check for the next element. I plus plus check for the next element. If the entire queue has been checked for the given key value and we have not found, so the moment your loop completes, when you come out of a loop, so you come at this position, and when you come at this position, we are simply saying return -1. Okay. So here we are saying that the key element does not exist, or the key element is not present in the given queue. Are we missing anything into this function? Please tell me. Are we missing anything into this function? Yes. We need to check something before performing the search operation. Yes, come on. Can someone answer me this? What do you need to check? Okay, good. You need to check if the queue is empty or not. Even if we do not check, suppose we are not checking, and conceptually we should do that. Theoretically we should do that. Even if we are not checking, suppose we are not checking, so in that case what would happen? In this case itself, we are not checking, and if we perform a search operation on an empty queue, let's see practically what happens. Then I will explain. Okay, so that function is the last function of the program, and then we have a main function, just like your main function of a queue stack. We have all the options inside a menu, which is inside the infinite loop, and then for every case, the first case is the insert. So we call the insert function properly. Then we check for the return value, and we do all the required things. Likewise, okay, interestingly, isEmpty, before calling the isEmpty function, before calling the delete function, we are checking for the isEmpty. Okay, here itself. So again, no need to check there. But we can put a check over there also. It's not a big deal, because if the queue is empty, so we will not be calling the function itself. Then the third case is for the search operation. Then fourth case is for display, and fifth case is to exit. So let's save this code. Let me compile this code, and let's try to execute it. Yeah, it says that there is an error. Display function. Display there. There's no error. It is perfectly fine. Okay, done. So now this is my application, and I double click on it. Now the program got executed. Now the options are insert, delete, search, display. So let's display. Let's try to display the fourth option directly. So the queue is empty. We are getting an output that the queue is empty. This one. Fine. Perfect. Let's check for the delete operation. again we are getting a message, queue is empty, you cannot perform the delete operation. Now let me go for the first operation, that is insert. We'll check for the search also, insert. So I want to insert say 10. So insertion done successfully, it saves me. And now let me display the queue. See what all information it displays. It says queue contents, then after that it says me the size of a queue, and the size of a queue is 5 because the value of max is 5. Then it shows us the value of front, that is 0. Then it shows us the value of rear, that is 0 because there is only one element now inserted. And now the values of the queue element, that is 10. If I insert one more element into this, say 20, insertion done successfully. And now if I display, see the values carefully. The size of the queue is 5. The value of the front is 0. It is pointing to the first element. The value of the rear is 1. It is pointing to the last element, which is the second element. And the first element is 10. That is the front of a queue. And the last element is 20. That is the rear end of a queue. Okay. Now let's delete. So now when we delete, which element should be deleted first? 10 or 20? 10 is at the front of a queue, 20 is at the rear of a queue. Insertion is deleted from the rear end, deletion is done from the, insertion is done from the rear end, deletion is done from the front end. So when we delete, the frontmost element should be deleted. That is 10 should be deleted. Okay. So I go for the second option, delete. And now we get a message that deleted element is 10. And now if I try to display my queue, see what does it say? It says me that the size of queue is still 5 because the value of max is 5. And the front is 1. Front is now incremented by 1 because one deletion has been done. Then the value of rear is also 1. And there is only one element into the queue, that is 20. If I do one more deletion, there is only one element into a queue. It is the front element, it is the rear element. So front and rear both are pointing to the same element, that is 20. And that's why the value of front and rear are same, that is 1. If you see here carefully, the value of front and rear both are 1 because at the one index value there is a element 20 and both are pointing to the same element, only one element into the queue. When we delete this element, when I go for the second option, so this is the last element of the queue. So after this, your queue will be made empty. And for that only inside the delete function, we have that check. Okay. If you are going to delete the last element, that is if queue of front double equals queue of rear. So in that case, we are writing queue of front equals to queue of rear equals to -1, else queue of front plus plus. Okay. So now the deleted element is 20. And now both front and rear are set to -1 because that was the last element. So if I try to display my queue now, it should say me that the queue is empty. And yes, it is saying us that the queue is empty. Okay. Now let me insert 3 elements and let me search. So I insert 10. Then I insert one more element, say 20. And then I insert one more element, say 30. I insert one more element, say 40. And I insert one more element, say 50. Now if I see the content of my queue, so it says that the size of a queue is 5, the value of front is 0, the value of rear is 4, and the queue elements are 10, 20, 30, 40, 50. Now if I try to insert any element, so my queue is full and accordingly I should get an output. So it is asking for me, it is asking for the data element. I put up 60 and now the message is queue is full. This is from your insert function. Because my queue is full, the size of the queue is 5. We have inserted 5 elements into the queue and now If I try to insert any more element, it says the queue is full. Now if I try to search the third option, and suppose I say the data element 30. So it says me that the key is found, that the given element is found at the location 2, which is perfect. 30 is present at location number 2. Okay. You had 10, 20, 30. So 10 is at 0, 20 is at 1, and 30 is at 2. So it is at location 2. If I try to search the element which does not exist, say 60, into my queue, what I have 10, 20, 30, 40, 50. I am searching for 60 and it should say me that the key is not found, and yes, the output is key is not found. Okay, so the functions are properly working in all these conditions. What we need to check for, that if the queue is empty and I try to search into an empty queue, so whether that code which we have written inside the search function is capable enough to handle that situation or not. So let's see that. How to do that? Keep on deleting from your queue. So first 10 is deleted because 10 is at the front location. That's why 10 is deleted. And then I delete one more element. 20 is deleted. I delete one more element. 30 is deleted. Then I delete one more element. 40 is deleted. Then I delete one more element. 50 is deleted, which was the last element. And now if I try to delete, so I should get a message that the queue is empty. And yes, we are getting the message that the queue is empty. Now, when our queue is empty. Now if I try to search into an empty queue, I go for the third option and I am entering, just see what happens. It asks me for the key element. I put up some key element, say 5. Now see carefully what is going to happen. It says key is not found. It says the key is not found. I go for the search operation again, and I say I want to search for, say, 60. Again it says key is not found. Okay. Now what's happening, see carefully. What we have done inside the main function, that we need to check first. Inside the main function, we are asking for the element to be searched here. We are simply calling the search function. If the return value is -1, we are saying key is not found. Else we are displaying the location of the key. So let's move to the search function and see what's happening there. This is my search function. I come here. When the queue is empty, my front is -1 and my rear is -1. Both are -1. Front is -1, rear is -1. Okay. So I equals to q of front. Then whether I is less than or equals to q of rear. Yes. Condition is true. And then it is checking for if q of data of I double equals k. So q of data of q of data of -1 double equals k. So how this statement is valid? Can someone tell me what's happening here? How this statement is valid? Q of data of I double equals k. When the value of I is getting -1, so Q of data of -1, which is invalid statement. Your program should terminate there. So how this case is getting handled? Yes. Can someone answer me? My question is, when the queue is empty, so what this would do? this condition is not fail. This condition doesn't fail for the first check. Your front and rear both are same. So this condition is true. So it comes inside the for loop and it checks for q of data of I, and I becomes -1. So it should check for q of data of -1 equals to k. And checking for -1 index value is an invalid statement. It's not a valid statement. So what's happening? Can someone answer me? Or take this as an assignment and you check yourself. Why we are getting a message key is not found. Instead, it should be like your queue is empty. You cannot perform the search operation into an empty queue. Okay, so you can check for that. It's a simple assignment for you people. And meanwhile, what we are seeing that our implementation of queue using array is done. It's completed. Okay. So now we are done with implementation of queue using arrays. So is there any query related to anything inside this program? If you have any query, please put up that query into the chat box, or you can unmute your mic and you can ask that query to me regarding anything into this program, please. Or we should proceed to the next topic. Yes. All the functions of this program understood to you clearly? No issues, no query. Should I proceed for the next topic? Yes. One student is saying yes. Should I wait for a few more students? Yes, proceed, sir. Proceed. Few more students, please give me some confidence that you have understood. And if you have understood, then we can move to the next topic. And for your kind information, if you do not understand the first topic, that is this queue, then it will be very difficult to understand the next kind of queue or next type of queue. So you should be very much clear about this queue and the different operations on queue. If you are quite comfortable with it, then we can jump to the next topic. Okay, so let's move to the next topic, and the next topic is basically types of queue. Now, there are different types of queue. The first type of queue is a linear queue. The queue which we have studied just now is called as a linear queue or the simple queue. Okay. Second type of queue is called as a circular queue. Third type of queue is called as a priority queue. And then the last type of queue is called as a double-ended queue. So basically there are four types of queue. First is the linear queue, second is the circular queue, then you have priority queue, and then last one is called as the double-ended queue. Okay. The queue which we have studied so far is called as the linear queue. The queue which we have studied so far is called as the linear queue. Okay, so linear queue we have already studied. That is also called as a simple queue. The second type of queue is called as a circular queue. And now we need to understand what is circular queue and why do we need a circular queue. Uh, there are some drawbacks or the disadvantages of your linear queue, and because of those disadvantages or those drawbacks, we need to go for a second type of queue which is called as a circular queue. Uh, Now, can someone tell me what are the drawbacks of a linear queue, which we have implemented just now? What are the drawbacks of a linear queue according to you? Any drawback you have seen so far when we implemented the linear queue? Let me execute or show you the execution of a linear queue. And from this, you let me know what is the drawback of a linear queue which we are seeing over here. Okay. This is our linear queue program which we have executed. Now, our queue is empty. If I try to display my queue, I get the message that the queue is empty. Okay. Let's start inserting something into a queue. So I insert 10, insertion done. I insert one more element, 20. Then I insert one more element, 30. Then I insert one more element, 40. I insert one more element, 50. So 5 elements I have inserted. When I try to insert one more element, say 60, I get a message that the queue is full. Perfect message that the queue is full. Okay. What we'll be doing now, let me delete. Okay, before deleting, let me show you the content of my queue. This is the content of a queue. Uh, there are some answers related to the questions. Farhan says it is time consuming. Uh, then the key says that even if we delete the number from queue, it still occupy the space. Then Amiruddin says it deletes from top. We don't have anything like a top in queue. We have front and rear. Then Anas says that for deleting element we have to delete every element before it. The deletion is always from the front end, so you did not have to delete any element before the front end. Then Hamza says that when an element is inserted in linear queue, then rear will be incremented by 1. Therefore, after insert, rear is shifted to last position in queue. It means now queue is full. Now, if a new element is inserted, then overflow will occur. Okay. I have one perfect answer into this among all these answers. And let me first show you, and then we'll get back to that answer. And I will tell you what is the perfect answer. Now, see the content of queue over here. What you can see that the size of a queue is 5, and then the value of the front is 0, and the value of rear is 4, and you have exactly 5 elements into this queue. So now we can very safely say that the queue is full. Of course, the queue is full. Now, after this, if I perform a deletion, so I go for the second option, delete. The frontmost element would be deleted, that is 10. So yes, the frontmost element got deleted, and I got a message that the deleted element is 10. Now if I try to display my queue, see here carefully. It says me that the size of a queue is 5. Yes, the size of a queue is 5. Then it says me that the value of front is 1 because one element has been deleted. Earlier it was 0. Front was 0. But one element got deleted. So the value of front became 1. Value of rear is still 4. And the elements are 10, 20, 30, 40. See here carefully. 10, 20, sorry, 20, 30, 40, 50. Elements are 20, 30, 40, 50. How many elements? 4 elements. Now, if I try to insert, I say I want to go for the first option, that is insert. It asks me for the element. I say 60, and when I hit enter, it is still saying me that the queue is full. It is still saying me that the queue is full. But practically, when I see my queue, when I see the content of a queue, so see here carefully, I still have only 4 elements. It means that there should be a space for one element because the size of my queue is 5 and I got 4 elements. But it is saying me that the queue is full. Not only that, let me delete one more element. What is the output? The deleted element is 20. And now if I try to display the content of my queue, the value of front is 2, the value of front there is 4, and the total elements are 3 in my queue. Still I try to insert an element, say 60. Still it is saying me that the queue is full. Though there are only 3 elements in my queue, and the size of a queue is 5, I still have a space for 2 elements. But still it is saying that the queue is full. Okay, I am not in a position to reuse those free slots. I repeat, we are not in a position to reuse those free slots. Okay, and even if I go for one more deletion, sorry, says queue is full, I go for one more deletion, 30 is deleted, I display the content of my queue, only 2 elements are there, there is a space for 3 elements, but still if I go for the insertion, I say that I want to insert 60, it says me that the queue is full. I go for one more deletion, 40 is deleted, if I see the content of my queue, it says that the size of a queue is 5, the value of front is 4, the value of rear is 4, and there is only one element, that is 50. Still if I want to insert and I try to insert an element, it still says me that the queue is full. It is still saying me that the queue is full. Can you tell me what's the reason for this? Can you tell me what's the reason for this? The reason is simple. What's the reason? The queue full condition is queue of rear equals max minus 1. The queue full condition is queue of rear equal max minus 1. This is the condition for the queue full. And this condition is perfect for the linear queue. And since because of this nature of a linear queue, once a queue is full, and when you start deleting the element from the front, this is my front, this is my rear. So when you start deleting the element from the front, your front pointer keeps moving ahead. So there is a space being created, but that space is not used, cannot be reused for inserting new elements, because your rear from where the insertion is done is reached to the maximum value, and that maximum value is max minus 1. I repeat, your rear index is reached to the maximum value. It cannot move beyond that. The insertion is done from the rear end, and rear is now max minus 1. You cannot insert any more element, though there is a space before the front, but you cannot reuse that space. You cannot reuse that space, and that is the biggest disadvantage of a linear queue. Wastage of a space or a wastage of a memory when you delete the elements. So when you delete the elements, your front is incremented by 1, and whatever space has been created before the front, that space cannot be used. That space gets wasted. Okay, and that is so clear from this very example that even there is so much space in your queue, only one element. Imagine that your queue is of size 1000, a linear queue. After deleting all the elements, there is only one element into a queue, and that element is at the last position. So there are 999 free slots, but still you cannot reuse those slots. Okay, that is the biggest disadvantage of a linear queue. Yes, the advantage is what? It is very simple to implement. You can easily implement a linear queue. But the disadvantage is what? Memory wastage. I repeat, memory wastage is the disadvantage. When you delete the elements, that deleted space, that free space which has been created out of deletion cannot be reused. Okay? Here in this case, the size of a queue is 5, front is 4, rear is 4, there is only one more element, there is only one element into the queue, but if you try to insert an element, you cannot insert. So the space which has been created after deleting the elements, you still have 4 slots into the array because the size of the array is 5 and there is only one element. So still you have 4 free slots, but you cannot reuse those free slots because the linear queue is implemented that way only. And that is the biggest disadvantage of a linear queue, memory wastage. To overcome this disadvantage of a linear queue, we have a second type of queue which is called a circular queue, which is called as a circular queue. Okay. So why do you have a circular queue? To overcome the disadvantage, to overcome, to overcome the disadvantage of a linear queue. And what is the disadvantage of a linear queue? Memory wastage. I hope you are understanding when that memory wastage occurs. So, to overcome the disadvantage of a linear queue, we have circular queue. Now, how that disadvantage we are going to overcome into a circular queue, and why do we have the name circular queue? That we need to understand now. Okay. So yes, the answer of the key was correct. He said that if you see this message, even if we delete the number from queue, it still occupies the space. Okay, and that is the disadvantage of a linear queue, and that disadvantage can be simply called as a memory wastage. And to come to overcome this disadvantage, we have the next type of queue, which is called as a circular queue. So what we'll be doing into the circular queue? How can we overcome this disadvantage? Any idea? The answer is there in the name itself. Circular queue. Queue is circular. What does it mean? Linear queue, a straight queue. Okay, linear queue, a straight queue. So if this is my maximum value, my rear is incremented by 1 after every, before every insertion. My rear is incremented by 1. Rear reaches this value, maximum value, and it stops. It stops there. Okay, because it is straight. Now front is incremented by 1 after every deletion. So though front is reaching towards rear, though there is a space before front, you cannot reuse that space. That's the problem of the linear queue. if somehow we make our rare index to move circular way so that it can come back to this position, so then it can start using the empty slots which has been created by the front after deleting the value. So my rare index can make use of this indices, which is free slots, which are free slots. Okay. So by this way we can overcome the problem of a linear queue. So we instead of linear implementation of a queue, if we implement the queue in a circular fashion, and if our indices are moving in a circular fashion, so in that case we can avoid memory wastage, or we can reuse the free slots which gets created after delete operation. Now how to do that? How to do that? How to make your indices to move circularly? That is the key of your circular queue. Okay. Generally, what happens? We move the rear and the front indices linearly, plus plus. Okay. So before every insertion, we are making rear plus plus, or we are writing queue of data in square bracket plus plus queue of rear equals to d. Okay, so before the insertion, we are incrementing the value of rear by 1. So linear increment plus 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 plus. Likewise, when you delete the element from the front, after deleting, we are writing front plus plus. Okay, so after every deletion, we are incrementing the value of front by 1. This is also linear. So the increment or the change in rear and front is linear. That's why the name of the queue is also linear. Now what we want, that this change in rear and front should be circular. That's why the name of a queue is also circular. How to move them circularly? Your answer is there itself. So in short, instead of plus plus, we need to do something else. What is that something else? To make it move circularly. I want to check the full condition. Come on. Get me some answer for this. Now I do not need this to be shown. So what I will be doing, let me stop the presentation and let me only share a window so that the size of the window will be bigger for you people. I am stopping the presentation and I am starting the presentation again, but this time I am sharing only my window of Visual Studio Code. Okay. So this way you will be seeing a bigger window. So please get back to me, give me some answer that how can we make the indices to move circularly, circular fashion में move करना है. Come on, you should have an answer for this. Get me some logical answer. Let me give you a hint. What does it mean? It simply means that if my value of max is 3, my max is 3, suppose. Okay, max equals 3. We'll start with a very simple example, and let me start only with one index, say there, and my rear is starting from 0. Okay, initially it will be having -1 value, but when I want to insert, so first it will be incremented by 1, so it will become 0, and then insertion would be done. The next value of the rear, when it is incremented by 1, it becomes 1. The next value of rear, when it is incremented by 1, it becomes 2. Now we cannot move beyond this 2. Why? Because this 2 is max minus 1. The value of max is 3. And this 2 is max minus 1. That is 2. Okay. 3 minus 1 is 2. So this equals to max minus 1. We cannot now linearly increment it. What we can do, we can come back to 0. And we should come back to 0. So after this 2, the next value of rare should be 0. Sorry. Then after 0, it should be 1. After 1, it should be 2. Again after 2, it should be 0. Then after 0, it should be 1. Then again it should be 2. And so on. If we are able to do this, it means that our rare is now started moving circularly. Our rare has now started moving circularly. Because it is starting from 0, then it is becoming 1, then it is becoming 2. 2 is my max minus 1. I cannot move to 3. I cannot make the next value of rare as 3. But I should be in a position to make it to the initial value, that is 0. So again I make it 0, then 1, then 2. So now it has started moving circularly. I repeat, now it has started moving circularly. This is the meaning of circular motion, a circular movement of an index value. Likewise, perfectly for the front. Front will also start from 0, then 1, then 2, then again 0, then 1 and 2, then again 0, then 1, then 2 and so on. How to do this? Mathematically or in coding, how to do this? When the queue is full, Hamza says that the queue is full and say the first element is deleted, add the new element to the starting position. Yes, perfect. In other words, reduce the value of front. Just a guess. No, front will not be reduced by 1. Instead, what we'll be doing, because the insertion is from the rare and only, the deletion is from the front end. So when you want to insert an element, you need to play with the value of rare. You cannot play with the value of front. Okay. So we will be moving in a circular fashion. So after 2, we need to come back to 0. That is the solution. So how to do that? Alfia says rare equals max minus 1. When rare equals max minus 1, rare equals to front. No. No. See, I am giving you an answer. We need to move circularly. Both the indices should be moving in a circular fashion. Both the indices, I repeat, both the indices would be moving in a circular fashion. So you need to just tell me now how you can move in a circular fashion mathematically, or when you code it, when we program it, how we'll be moving in a circular fashion. I give you a hint again. 0, 1, 2, after 2 it should be again 0, then 1, 2, then after 2 again 0, 1, 2. Hamza is saying rare plus 1 mod max equals to 0. Hamza is saying to make use of a mod operator. Perfect answer. Correct answer. We need to make use of a mod operator. Now I mean to say this operator, mod operator. Now what is this mod operator? What is the use of a mod operator? Can someone tell me what is the use of a mod operator? See, we should understand the concept. Then only we should move ahead. Otherwise, it's not a big deal. I can directly show you the program. I can show you the condition. I can explain your condition within say 2 to 3 minutes. Done. I don't want that. I want you people to understand it better. And then when I show you the condition, inshallah, you yourself will be in a position to understand it. It gives us a remainder. Perfect answer. When I say 3 mod 2, what is the answer of 3 mod 2? 1. Yes. 3 divided by 2. So the question is 1 and the remainder is 1. Okay. So 3 mod 2 is 1. If I say 5 mod 2, what is the answer? 5 mod 2. Again 1 because the remainder is 1. If I say 4 mod 2, What is the answer? Answer is 0 because the remainder is 0. Okay, right? Perfect. Now, see here carefully what I am writing, huh? And what I mean to say. When I am saying for mod 2, I am getting 0 remainder. And when I say 1 mod 2, what is the answer? Or before that, sorry, before that, let me write 2 mod 2. When I say 2 mod 2, what is the answer? Again 0. Okay? Because 2 divided by 2, question is 1, remainder is 0. When I say 1 mod 2, what is the answer? What is the answer? 1 mod 2. 1 mod 2, the remainder is 1. Why remainder is 1? Because this is integer division. Okay? So question would be 0. 2 zeros are 0. 1 minus 0 is 1. So your remainder is 1. Question is 0. I repeat, your question would be 0 and your remainder would be 1. Okay? So 1 mod 2, your answer is 1. Okay? On contrary, I can say for a modulus operator, if a smaller value is divided by a greater value, if a smaller value is divided by a greater value, the answer is the same smaller value. The answer is the same smaller value because that cannot be divided. So your question would be always 0 and your remainder would be always the same number. Which number? That is the smaller number. Okay? So 1 mod 2 equals 1. It means that, I take another example, 3 mod 3 is what? 0. 3 mod 3 is 0. If I write 2 mod 3, then the answer is, come on, smaller number divided by 3, smaller number modulus bigger number, your answer is smaller number. So the answer is 2. 2 mod 3 is 2. 1 mod 3 is 1. 0 mod 3 is 0. 0 mod 3 is 0. Okay? Do not go into the mathematical formulation that how 0 can be divided. 0 mod 3 is 0. You need to only remember that. See these statements carefully. This is the solution for all the problems of a linear cube. Okay? This is a solution for all the problems. What I said you, we need to move in a circular fashion, right? 0, 1, 2, then 0, 1, 2, then 0, 1, 2, then 0, 1, 2. How you will be doing that? The value of max is 3 in this example. Okay? 0 mod 3, 0, 1 mod 3, 1. Okay? 2 mod 3, 2, 3 mod 3, 0. We are coming back to 0. This is important. 3 mod 3 is 0. I repeat, 0 mod max 0, 1 mod max 1, 2 mod max 2, 3 mod max 3, max minus 1 mod max equals to max minus 1, and then finally max mod max equals to max mod max equals to, come on, max mod max equals to Same number. 3 mod 3 equals to 0. So max mod max equals to 0. So you are coming back to 0. 0 mod max 0, 1 mod max 1, 2 mod max 2, 3 mod max 3, max minus 1 mod max equals to max minus 1. Because max minus 1 is 1 less than max. Max minus 1 is 1 less than max. So max minus 1 mod max equals to max minus 1. Then finally max mod max equals to 0. So we are coming back to the initial value. So this is the funda. This is the concept. Based on this concept only, you have all the operations of a circular cube. Based on these operations only, based on this concept only, you have all the operations of a circular cube. Okay? So we will be smartly making use of a modulus operator. I repeat, we will be smartly making use of modulus operator in a circular cube. We'll implement a circular cube, and with the help of a circular cube, we will overcome the disadvantages of a linear cube. What was the disadvantage? Memory wastage. That was the biggest disadvantage of a linear cube, and we will overcome that disadvantage in a circular cube with the help of a circular motion, and the circular motion is implemented with the help of a modulus operator. The circular motion is implemented with the help of modulus operator. And why modulus operator is used? For a very simple reason. A number mod same number gives you 0. Okay? Lesser number mod greater number gives you lesser number, or smaller number mod greater number gives you smaller number. Okay? So for this reason of a modulus operator, or for this nature of a modulus operator, we are making use of a modulus operator. So whenever you want to move in a circular fashion, always remember, whenever we want to move in a circular fashion, we'll be making use of a modular operator. Whenever we want to move in a linear fashion, so plus plus and minus minus, increment and decrement operator. Whenever you want to move in a circular fashion, we'll be making use of a modular operator. Okay. Now let's see how we'll be making use of a modular operator in a circular queue, and how we'll be implementing a circular queue. Otherwise, your circular queue and linear queue are same. Only the motion is handled in a different way. In linear queue, it is linearly handled. In circular queue, it is circularly handled, and that makes a difference between the two queues. And we overcome all the disadvantages of a linear queue into a circular queue. Okay, let me show you circular queue. This structure would remain same. The structure of a queue remains same, no change into this at all. The initialized function also remains same. The initial values of both the indices would be -1 only. Yes, the is full condition. The is empty condition would also remain same, -1. That is the initial value, so that will be a checking for the empty queue. What about is full? When can you say that the circular queue is full? ये full condition का ऐसा problem था linear queue. So what should be the full condition for a circular queue? When can you say that the circular queue is full? They are moving in a circular fashion. Both the indices are moving in a circular fashion. When can I say that the queue is full? A circular queue is full. Yes. Come on, get me some answer. I can see the chat box. Please put the answer into the chat box. This is a full condition for a linear queue. I do not want a full condition for a linear queue. Else it will be a linear queue only. I am implementing a circular queue. So what's the condition for a full circular queue? When can I say that the circular queue is full? Any idea, any concept? Both the indices are moving in a circular fashion. Okay. So when can we say that there? Hint for you, there is nothing in between, or when the things are moving in the circular way, so your rear is pointing to the last element, your q is pointing to the frontmost element. Okay. And in a linear queue, what happens? Your front moves ahead, so space is created behind front. Now in circular motion, we say that in circular queue, this rear would be moving in a circular fashion, so that it can reuse the space created by the front after deletion. Okay. Now, when can you say that the queue is now exactly full? There is no free slot. There is no free slot in the queue. And I give you a hint. There is nothing free in between your front and rear when they are moving in the circular fashion. So in between your rear and front, basically, not front and rear. Between front and rear, you have all the elements. So I say you that there is nothing free between rear and front when they are moving in the circular fashion. So there is nothing free in between rear and front. All slots are occupied. When can you say that? Rear and front equals rear equals to front minus 1. I am getting one answer that when rear equals to front minus 1, then your queue is full. Rear equals front minus 1. Yes. Right answer. Anybody else? Anybody else? Only one answer I am getting from one student I am into. Rear equals front minus 1. To a point, up to a point. Anything else into this? I need to check circularly. Let me show you. This is my circular flow. Now please see it carefully. The condition. Your front is just behind your rear circularly, or you can say your what you can say. Sorry, your rear is just behind your front circularly. Okay, or the front is just ahead of your rear circularly. Alfia said that rear equals to front minus 1. So she was correct. Rear equals to front minus 1, or I can say front equals to rear plus 1. One and the same thing, but circularly. That is most important. If you do not check for this circular condition, then our answer is half. Answer is still incomplete. And in terms of programming, there is nothing like half. Either it is right or it is wrong. Though her attempt is very good, she was to the point, but the only thing remain is in a circular fashion. That is most important thing. Okay. So here the condition is what? If Q of front double equals Q of rear plus 1 mod max. This is important. So now we are checking for a relation between front and rear, but in a circular style. Okay. So Q of rear plus 1. It simply means that front equals to Q of rear plus 1, but in a circular style. So another answer was your front is 0 and your rear is max minus 1. So in this case also your Q is full. Yes, perfectly your Q is full when your front is 0 and rear is max minus 1. Check for this condition. Q of front double equals Q of rear plus 1. Your Q of rear is max minus 1. Okay. So max minus 1 plus 1. That is max. Max mod max is 0 and your front is 0. It means your Q is full. Now when you move the Q in a circular fashion, for example, there is a situation and in this situation you have started using the free slots which were created by front after deletion. You are not able to see this situation which I am showing using. Do you remember in a linear queue when we started deleting the elements? Let me show you. Now for that again I need to stop my presentation and I need to share the full screen. Let me do that. We will only see that and we will stop because that is important to understand. Once you understand this, your circular queue is done, you can say. Okay, so my complete presentation is on. This situation. In this situation, we can easily see that there is only one element into the queue and still it is saying that the queue is full because this is a linear queue and our front and rear both are 4 4. Okay. Imagine it to be a circular queue. So when we start inserting now, our rear will start moving in a circular fashion. Okay. So rear would become 0. At the 0th index value, we will insert one element. Then rear will become 1, we will insert one more element. Rear will become 2, we will insert one more element. Rear becomes 3, we insert one more element. Now can you insert any more element into this? Please answer me. Now can you insert any more element into this? Yes. Your rear is 3 and your front is 4. Can you insert any more element into this? No, you cannot insert any more element into this. Why? Because your rear is 3 and your front is 4, your queue is full. What is it means? See carefully. Front is 4, rear is 3. Front is just above your rear. Front is just one more than your rear. I repeat, front is just one more than your rear. Front is 4, your rear is 3. Front is just one more than your rear, but this has to be done circularly. That's why we are putting the mod max. Okay. So your Q of front equals Q of rear plus 1. Q of rear. Rear is 3. Q of rear plus 1 means 3 plus 1 is 4. 4 mod max. Max is my 5. So 4 mod max is 4 and front is also 4. So I can safely say that my circular queue is full because this condition is true. So are you getting it? If this condition is not true, take an example. There is a free slot between front and rear. Same example, the value of front is 4 and now the value of rear is 2, not 3. So now the value of rear is 2, value of front is 4, there is a free space. There is one single slot between front and rear where your insertion can be done and your circular queue is not full. So in this case, My front is 4 and my rear is still 2. Okay. So what I would be checking for? Q of rear plus 1. So 2 plus 1 is 3. 3 mod max, that is 3 mod phi is still 3, and my Q is, my front is 4. So 4 is not equal to 3. 4 is not equal to 3. This condition is false, and then we'll be returning 0. It means that our Q is not full. Our Q is not full. Okay. So I hope you are understanding this, and with this we stop our today's session, and I will be sharing now our attendance and feedback form with you. You can give your attendance and feedback, and I hope you are understanding. Still, if there is any question, any query, please put up your query into the chat box, and we can discuss on those queries. Still, if there is a query, please put up your query into the chat box, and we can discuss on those queries. And meanwhile, let me share with you our attendance form. I'm sharing a link for the attendance, but please give me some queries so that we can discuss on them. Means Q is full when rear plus 1 equals max and front equals rear plus 1. Yes, but instead of putting the multiple conditions, you can simply put one condition which we have discussed. Front equals rear plus 1 circularly. That's all. Front equals rear plus 1 circularly. If this is the case, I can safely say that my Q is full. Okay. See why I am saying circularly, because imagine that your front is 0 and your rear is max minus 1. So in this case also your Q is full. So but when I put up a condition front equals rear plus 1. Okay. So in this case your front is 0, and when you compare it with rear plus 1, rear was max minus 1, so rear plus 1 means max. So front is 0 and max is 5. So the condition is false. That's why we check it circularly. But when we put up mod max, so max mod max is 0 and front is 0. So 0 equals 0, condition is true, your Q is full. And that's why front equals rear plus 1 mod max. If front equals rear plus 1 mod max, we say that the Q is full. Let me stop the recording. This recording is getting stored into the drive of Mapari Simran.